Okay, we're going to continue with our final subsection of chapter 2, that is membrane filtration, sedimentation, and centrifugation. So at the end of this chapter, we should be able to understand flow of fluid through filter, evaluate various separation process, for example filtration itself, and centrifugation, review application of various separation process in food industry. So if you can see at the diagram shown here, this is example of cake. What is cake? Then we're going to look into it in this chapter later on. So what is filtration actually? Filtration is actually a process that involves separation process, and it involves a phase separation. It can be between gas to or liquid, vapor and liquid, liquid with liquid, and liquid and solid. And this separation process involves at the molecular level of the materials. So molecules are diffusing or vaporizing from one phase to another, or the different chemical properties of the liquid system will help in terms of the separation process between the different phases, and it's also involved physical to chemical processes. This separation process can be said that it involves mechanical or physical separation. Mechanical or physical forces will act on the particles or liquids or mixtures instead of the single molecule. The classification that we can do for this mechanical or physical separation or filtration. Second is the settling and sedimentation. This usually you can see in a water treatment, jar test. And then the third one is centrifugal settling and sedimentation. So centrifugation, this is a common process that you use in analysis experiments, and I believe a lot of you have done this centrifugation process. And number 4 is centrifugal filtration, and number 5 mechanical size reduction and separation. So the forces include gravitational and centrifugal, actual mechanical and kinetic forces arising from the flow. I believe everyone remember we have learned and covered this effects of gravitational force in fluid flow, where the particles will initially contain a kinetic energy, and then it will start to slow down and it will settle at the particle can settle at the bottom of the flow. Here is an example on application in food industry. For example, if we take a juice, so we want to remove unwanted particles, or we want to concentrate the juice, and what we do is we filter it. And sometimes filtration is are used to recover solid process or solid products, as well as sometimes we want to purify our product to get a premium or a certain quality that we want to achieve. So in food industry, for example, in juice production, if you want to concentrate it, so we have a slurry solution, and then we will have the media of the filter, and after a while it will build what we call as cake, which is the solid or any particles that are filtered or that are phase separated with the liquid or the filtrate. So this will form a filter cake. As you can see here depicted in the schematic diagram on the left hand side. So this is a simple example of how filtration works and how this cake that we mentioned earlier in this lecture. These are two common examples of types of filtration in the industry. So we have rotary drum vacuum filter with a scraper discharge, and we do have a plate filtration. If you can see, for the rotary drum vacuum filter, what happened is the drum will rotate and touch the slurry of our liquid, and there's a vacuum that will be the force that suck the slurry, and this slurry will pass through around the surface of the rotary drum and be filtered out to this filtrate vacuum receiver. Here, as you can see, we have a valve and then there's a filtrate flow line, and after a while, cake will be built up surrounding this rotary drum, and there's the function of knife blade to actually cut this cake and filter the cake out. So it is quite a smart design. And similarly for the plate filtration, so we do have the filter media, and after a while it will build and make a cake, and the filter cloth, you can see here we do have a filter cloth, filter plate, and the frame that hold this filter itself, and we can get the concentrate that we want. Okay. It's a process related to mass transfer, and it's actually in this chapter we're going to look into a mass transfer restricted to migration of constituent of a fluid or a component of a mixture. So migration occurs because of changes in physical equilibrium of the system caused by the concentration differences, and this concentration gradient is the driving force. There are a number of similarities between mass transfer and heat transfer. Example, flux, gradient, resistance, transfer coefficient, as well as boundary layer that occurs during this process of separation. So if we can recall the second law of thermodynamics, the system that are not in equilibrium tend to move toward equilibrium by time it will tend to move toward achieving equilibrium. So we already mentioned this, that the process of separation, or we can say the diffusion process of the particles, are occurring at molecular level, or scale and bulk transport of mass due to convection flow. In food industry, sometimes these processes can involve suspensions that contain significant amount of insoluble solids, or we want to do a clarification or a microfiltration. So here we can see two types of filtration. The first one is surface filtration on the left, and the second one is depth filtration. So what are the difference? If you can see, the red spheres are the retention particle, the green smaller sphere is the permeate particle, and the center bit here is the porous ceramics, or we can say as the filtration media. Okay, so for surface filtration, you can see the retention particle are on the surface of that media and it doesn't pass through it. This is because the particles are retained at the surface, and then because of the media pores, media have a pores that is smaller than the particle that we want to retain at the surface. Okay, the smaller particles then pass through the openings, and then example of this process is when we use filter paper or porous media, or as well as cloth. This is a common way of you filter out your materials in the lab where you use a filter paper. And for this surface filtrations, we have two way of doing it, which is depth and cross flow. You can see here an example of how the process takes place. And for depth filtration, you can see the red particles. Some of it are captured in the pores of the filter media. So what happened is our flow of feed stream will flow through a thick layer of porous materials. For example, the fibrous materials of filter media at a particulate or sand structure, and this sand structure or fibrous materials will retain particles due to collision of fibers or particles of filter medium or by adsorption. Okay, so example of the materials is glass wool, rock wool, and the passages are larger than size of retained particles. So that's why it can capture this retention particle in its pores. And sometimes how this type of filtration is designed is by having a multiple layers of filter media so that it can retain a certain amount of the particles and in its pores.